Large language models. For those who don't know, Three Blue Brown is going to explain for you hoes.
Imagine you happen across a short movie script that describes a scene between a person and their AI assistant. The script has what the person asks the AI, but the AI's response has been torn off. Suppose you also have this powerful magical machine that can take any text and provide a sensible prediction of what word comes next. You could then finish the script by feeding in what you have to the machine, seeing what it would predict to start the AI's answer, and then repeating this over and over with a growing script completing the dialogue. When you interact with a chatbot, this is exactly what's happening. A large language model is a sophisticated mathematical function that predicts what word comes next for any piece of text. Instead of predicting one word with certainty, though, what it does is assign a probability to all possible next words.
Technically, if it's a mathematical thing and, we don't have the best mathematicians that could solve the hardest problems, and Open O four just solved one of them problems that mathematicians won't be able to solve for about 15 years. At what point do we realize that making this sentinel of a product is just going to kill us in the end of the day?
To build a chatbot, what you do is lay out some text that
I guess it's not adding up.
describes an interaction between a user and a hypothetical AI assistant. You add on whatever the user types in as the first part of that interaction, and then you have the model repeatedly predict the next word that such a hypothetical AI assistant would say in response, and that's what's presented to the user. In doing this, the output tends to look a lot more natural if you allow it to select less likely words along the way at random. So what this means is even though the model itself is deterministic, a given prompt typically gives a different answer each time it's run. Models learn how to make these predictions by processing an enormous amount of text, typically pulled from the internet. For a standard human to read the amount of text that was used to train GPT-3, for example, if they read nonstop 24/7, it would take over 2,600 years. Larger models since then train on much, much more. You can think of training a little bit like tuning the dials on a big machine. The way that a language model behaves is entirely determined by these many different continuous values, usually called parameters or weights. Changing those parameters will change the probabilities that the model gives for the next word on a given input. What puts the large in large language model is how they can have hundreds of billions of these parameters. No human ever deliberately sets those parameters. Instead, they begin at random, meaning the model just outputs gibberish, but they're repeatedly refined based on many example pieces of text. One of these training examples could be just a handful of words, or it could be thousands, but
So if it's refined, that's like a math thing, right? So there's certain things that we should probably understand about the computer's reasoning that we're probably not. So I don't really know how comfortable people are with AI ethics, but this should be one of the prime things held on a poster like, yo, this motherfucker thinks on his own already. Some of this shit that y'all saying he doing, he been doing. Let's kind of like sit down and talk about it.
in either case, the way this works is to pass in all but the last word from that example into the model and compare the prediction that it makes with the true last word from the example. An algorithm called backpropagation is used to tweak all of the parameters in such a way that it makes the model a little more likely to choose the true last word and a little less likely to choose all the others. When you do this for many, many trillions of examples, not only does the model start to give more accurate predictions on the training data, but it also starts to make more reasonable predictions on text that it's never seen before. Given the huge number of parameters and the enormous amount of training data, the scale of computation involved in training a large language model is mind-boggling. To illustrate, imagine that you could perform 1 billion additions and multiplications every single second. How long do you think that it would take for you to do all of the operations involved in training the largest language models? Do you think it would take a year? Maybe something like 10,000 years?
Not in
The
this
answer is
lifetime.
actually much more than that. It's
Yeah.
well over 100 million years.
Yeah.
This is only part of the story, though. This whole process is called pre-training. The goal of auto-completing a random passage of text from the internet is very different from the goal of being a good AI assistant. To address this, chatbots undergo another type of training, just as important, called reinforcement learning with human feedback. Workers.
You know what's crazy? I was watching a video about all of this, I guess, on a more humanitarian level. Yo, y'all gotta watch out for some of these tech giants. They know what the technology is, just not rolling it out to the public in the same way they're getting it. So we might have a watered down version of what the fuck they got, which is already known, but when it comes to what they're trying to achieve, it's really like space or extraterrestrial. That's all it really boils down to, because a motherfucker really doesn't care about automating tasks every day. Look how boring that got after years of working with each other. We want people to do the work for us now. Like we're in that era. Now it's going to take years and years and years just to get next to whatever extraterrestrial, whatever thing we call the source. And at that point, we're going to see what happens. Because remember, every time we try to get closer to God as humans, even in biblical terms, God makes sure to divide us further and further away from the truth. So,
Flag unhelpful or problematic predictions, and their corrections further change the model's parameters, making them more likely to give predictions that users prefer. Looking back at the pre-training though, this staggering amount of computation is only made possible by using special computer chips that are optimized for running many operations in parallel, known as GPUs. However, not all language models can be easily parallelized. Prior to 2017, most language models would process text one word at a time. But then, a team of researchers at Google introduced a new model known as the transformer. Transformers don't read text from the start to the finish. They soak it all in at once, in parallel. The very first step inside a transformer, and most other language models for that matter, is to associate each word with a long list of numbers. The reason for this is that the training process only works with continuous values, so you have to somehow encode language using numbers, and each of these list of numbers may somehow encode the meaning of the corresponding word. What makes transformers unique is their reliance on a special operation known as attention. This operation gives all of these lists of numbers a chance to talk to one another and refine the meanings that they encode based on the context around, all done in parallel. For example, the numbers encoding the word bank might be changed based on the context surrounding it to somehow encode the more specific notion of a riverbank. Transformers typically also include a second type of operation known as a feed-forward neural network, and this gives the model extra capacity to store more patterns about language learned during training. All of this data repeatedly flows through many different iterations of these two fundamental operations, and as it does so, the hope is that each list of numbers is enriched to encode whatever information might be needed to make an accurate prediction of what word follows in the passage. At the end, one final function is performed on the last vector in this sequence, which now has had a chance to be influenced by all the other context from the input text, as well as everything the model learned during training, to produce a prediction of the next word. Again, the model's prediction looks like a probability for every possible next word. Although researchers design the framework for how each of these steps work, it's important to understand that the specific behavior is an emergent phenomenon based on how those hundreds of billions of parameters are tuned during training. This makes it incredibly challenging to determine why the model makes the exact predictions that it does. What you can see is that when you use large language model predictions to autocomplete a prompt, the words that it generates are uncannily fluent, fascinating, and even useful.
honestly, large language models and this explanation is no different than what Siri has when you can autocomplete on your phone right here. Oh, let me just choose a conversation with myself. So y'all know it's like not that revolutionary. This stuff right here, you could just, well, I did it, huh? With this stuff right here, you could just kind of like guess we are going to be in the car. See, autocomplete right then and there. And I think that was the first understanding of what computers can do, and then we transformed it into LLMs and everything. Just the math part of how long it takes to get to that answer is going to really boil down to how much energy we're willing to waste. It's a lot of energy we're talking about here. It's easy to make some shit like this. It's harder to make something as instantaneous as LLM to give a response to a human and for it to be accurate and cohesive like a human. Like we trying to replicate God's greatest gift. Like we are God's greatest gift. We trying to replicate it, my nigga. Like we can't. We not God. We can't remake us. Sorry. You not even like us, my nigga. You just you. Everybody a specific version of themselves. Y'all gonna fuck around and make Satan, nigga. I keep telling y'all, y'all just gonna make y'all just gonna make Satan, bruh. That nigga not gonna have no human feelings. We gonna operate off money only. It's gonna be like a new indoctrination of slavery, bruh. It ain't just gonna have colors though. It's just gonna be robots versus humans. We gonna call it a different word, but it's just slavery. Nobody wanna work today too. Like, come on now. Them niggas got this shit so set up, yo. They niggas do not want to work. It's not even like niggas is broke. They just don't want to clock in to work. How the fuck you got a whole group of people in a nation that just don't want to work? They waiting for the robots. Like, yo, come enslave us. That's basically what they saying.